All right, guys, well, welcome. Thank you so much for coming this afternoon to our Target Teach session. So Target Teach is a little different than a flipped follow-up session. We are going to specifically talk about this drop and bounce lab that you guys had on your calendar for yesterday. I do want to make sure that we cover the policy on late, or I don't even want to call it late work. So as we get started, we're going to go through and talk about that, but I want to make sure before we get going that you guys remember our communication guidelines. Please make sure your chat is appropriate and that you're focusing on the content, appropriate language, make sure that you're not changing personal information in class, and those kinds of things. If you would like to be on webcam, you're welcome to jump on. So feel free to do that. And then just a couple of reminders for class etiquette. You need to keep the chat focused on the content. So questions are great, but spamming is not. Let's see, if you want to get rid of notifications, Tia, you'll go under chat. There is, it says chat, and then over to the far right, there's a little box. So drop down and just uncheck the box that says show event messages. Uncheck that. Yeah, and then that will keep them, I think, from popping up most of the time. All right, yes. So keep the chat focused, keep your chat comments kind of appropriate. Remember, I can see all private chat. And then finally, live sessions are not required. So if you are going to come in and be, you know, a chat spammer or not an interactive participant at all, then please remember that you do not have to attend these. So if you have other things that interest you more, you can do that. But for those of you that are here and wanting to get this information, we want to keep the chat clear and focused so that everybody can get questions answered. Alrighty. So as we jump in, I'm going to go back. I know some of you came in a little bit late. We are covering the drop and bounce lab. I want to ease your mind for those of you who are maybe concerned a little bit with grades or assignments missing or things showing up as past due. So when you see something like that, like the date has passed, just remember that you guys have up until the permanent zero deadline to submit your teacher graded assignments. And so permanent zero deadline means halfway through the course. So for you guys in August, that means November 2nd. So if you have something that just shows overdue, there's no need to panic on that as long as you don't have like 10 assignments overdue. But 1, 2, 3 of those, that's okay. You're working. You want to try to stay close to the course calendar, but it's not counting off points. It isn't giving you a 0, anything like that. So don't panic on that. All right, so if you are going to be editing your file or you're going to be adding to, this is the place to do this. All right, so this will go probably half an hour, maybe a little over, depending on how long it takes to go through. So if you have to leave, then you're able to head out if you need to. I like to keep them at about a half hour, but sometimes labs take a little bit longer. All right, so a couple of things to remember when you're filling in and watching a session, whether you're watching this as a recording or you're here live, you can fill in the answers as we go along together. That's okay. But please do not screenshot, like if we create a data table together in the session, please don't screenshot that and put it into your work. That would be a not okay thing to do. But you are able to use the answers and things that we go through together in the session, even in the recording. I understand that sometimes students need a little bit more guided help on that. So it's not a problem, but if you screenshot answers and put those in, that means you're just copy pasting, and so you're not really doing it. And then be sure that each page of the lesson, back when you go into the lesson, that is checked off. And I'll kind of show you what I'm talking about as I screen share in just a minute. Let's take a look at that. So when you get over back to this page or the 1.11, you want to make sure that all of these have a check. So if you're watching the recording or you're doing this lesson with me and you're looking at my screen images instead of going into it on your own, then make sure that you check those off. Yep, there is likely lag. That is an issue that can happen with Blackboard. So sorry about that. All right, so Kayla, I can see your private chat. I will connect with you after if you would like on that. All right, guys. So let's go on and take a look at this together. So grab your assignment page if you want to take notes. The file is in the lesson. So you will see that in 1.11. Or if you're talking about how you download, so Maya just helped me figure out which file you're referring to. That way you can make sure. All I'm talking about is the file that is in the lesson. All right, so what I want to do is show you guys, I've had a lot of students that are having a hard time understanding that our lessons do connect and build on each other, and so they did the 1.8 drop and bounce lab, but by the time they got to 1.11, they had no idea those were connected. So we're going back and kind of connecting all those dots in this. So the file that showed up when you came in was a file, let's see, in the file transfer. So it'll allow you to save it. It's just the exact same file. Yeah. Same file that's in your lesson, just the Word document. All right, so you should have it again. All right, so we're going to talk through completing the lab report today, but again, we're going to go back and connect those dots over what you did in 1.08. All right, so in 1.08, you guys were given this information about what we're testing. So how does the temperature of a bouncy ball affect its bounce height? All right, so we will attempt to find the answer to this question in the lab experiment. All right, so it does guide you through a little bit of how we're getting started. So now I'm going to screen share with you. I know it might cause some lag, so bear with me, guys, on that. We're going into the lab portion, and just because you guys haven't done a lot of this before, you will see I had a lot of students email me, question, I don't have the materials, things like that. So this is a virtual lab. It shows you in the first few pages. So on this page, it's just saying follow the directions on the screens to conduct the lab. So if you were not understanding that it's a virtual lab, you'll see in just a minute. Here's your lab report. It is a Word document. You do have to have Microsoft Office or Office 365, and you do get that included with your student account. So you have to navigate that through Outlook, and I can share a link with you on how to do that if you're struggling with that as well. Okay, so everything that you'll open up in these links are going to be Word documents, PowerPoint, something like that. So you do need the Office 365 products in order to be able to open and type on those. All right, so that's page 1. That is where the lab report is. Thank you guys for in chat if you're helping out those students who are new and a little confused. I appreciate you guys adding in that information. Yeah, they'll show you how I'll show you that at the end. It's in your Outlook and Student, and you'll find it pretty easily. All right, so as we get going, how does the temperature of a bouncy ball affect its height? So you will find the answer to this question in our lab experiment. So before beginning, we're going to formulate a hypothesis. So I'm playing the video. On your end, it might look blurred, distorted, laggy, all kinds of things could be going on. But you're thinking about a hypothesis. What do you think with the temperature of the ball? Do you think it changes anything about how the ball bounces? All right, so you're starting to form your hypothesis. So Cole says the hotter it is, the higher it bounces. Lots of things could be going through your head. You're just posing a question that you are going to test. All right? So student A says, if the temperature of the ball affects bounce height, then the ball will bounce higher when it's warm. And student B says, if the temperature of the ball affects bounce height, then the ball will bounce higher when it's cold. So you can see that there are different opinions here, and that is totally fine. You want to test it. So it's okay if your hypothesis is wrong. You're just testing it. And yes, there is going to be a recording of each session. All right, so this is where you would plan out and conduct your investigation. You're naming the variables. What should you keep constant? And so that's an important thing to know and understand. And so in the experiment, you're looking at the bounce height of a bouncy ball at several different temperatures, and you want to consider the following to plan your investigation. So what is your independent variable? All right, your independent variable is the thing that you change. So what do you guys think we're changing? Pretty easy. We're going to change one thing. Any ideas? What are we changing in our experiment? You're right, Cole. Yes, we got it, the temperature. So we're changing the temperature. That's our independent variable. So our dependent variable, okay, this is the variable that we observe. Okay, so what are we measuring? So we're measuring the bounce height after we release the ball. That is our dependent variable. And then what are the things that we would want to keep constant? Because we can only measure one thing at a time if we're changing different factors. So what do you guys think? Yes, that's a good example, Kayla. The kind of ball we used. Oh, that's funny. All right, yes, so the material. We want to keep, another thing here they say is the height from which the ball is released. So you guys, if you remember from the experiment, you dropped it from a certain height, so we wouldn't want to change that for every different ball or temperature. We want to keep the height the same. And the type of ball, that's a great example as well. And so what tools do we need to do our experiment? We need a meter stick and some bouncy balls, right? Pretty easy. So the next thing it asks you to do is construct a data table, because we do have to record all of our information, and so we need to make our data table. And so real quick, I'm going to share with you so that you guys that are going along with me are able to have a data table. Let me put it here. So if you remember from 1.07, you guys were instructed on how you create a data table. And they were kind of showing you an example similar to what we might do. So it needs a title. Your data table needs a title. What are we measuring? So this would be maybe the height, the temperature, trial 1, 2, 3. Okay, so your data table, you need something already put together when we start so that you can fill in your different times and heights and things like that. Okay, so we're not really going a distance in this. We're dropping it from the initial drop height you may want, how high it bounced in trial 1, 2, 3. So think through that. And if anybody would like to share on how they presented, what they used as their categories. So if you want to share what you used here, then you could definitely do that. All right, so type of ball and then the average bounce height. Great, Cole. It did say you want an average. That was an important thing that they included. That's okay, Amanda. I know it's happening to a lot of you guys. So you need an average column. We're not measuring time in this lab. We're measuring the height, ball bounce height. And then initial height. Yeah, you do want to see your other columns. Yeah, but the balls were different. They looked different. They had like some different characteristics, and that's how we knew maybe the temperature. So you definitely have to record on there or be able to tell which. No, you just need an average at the end. So the ball that's a certain temperature, there was one that, yeah, Kayla, I see it. I'll have to look at it after the live session. Yeah, so ball temperature, ball, the bounce height after each drop, and then the average height. That's perfect. Amelia, that's exactly how you should set it up. Great. So some of you probably have something very similar to that. All right. So as long as you have that ready and you're ready to start kind of recording some of this stuff as we go through, then you're in good shape. All right, so we're going back, sharing my screen again. This is 1.08, so this is where you did the actual experiment. So we're using the simulation. Again, there were no pieces of lab equipment required for this lab. You were just doing the simulation here. And it said before testing the effect of the temperature on the bounce height, you have to conduct a control test to make sure all the balls bounce the same. So right now, all the balls are the same temperature, and they're identical except for the stripes. So you may need to identify plain, one stripe, two stripe, however you want to call those. And so it says to raise each ball to 70 centimeters and test to see if they reach the same bounce height on their first bounce. And then you proceed to the second part. So right now we're just getting a control. You want to make sure when you raise the ball up that the bottom is at the 70 centimeter mark. And then you guys watch closely. There may be a little lag, but tell me when you bounce it, you've got to look where, when the ball bounces up, on the very first bounce up, where is the bottom of the ball? That's how you measure. All right, so I'm going to drop it. 3, 2, 1. So did you guys see? I'll do it again. I think it's kind of hard to see. Did you guys see the bottom of the ball is where you have to measure the initial height? Yeah, a lot of lag. Oh, Ryan, you can't see anything either. Okay, sorry about that. So I'll kind of show you. I think it looks like 20. Am I wrong on that? Did you guys that already did it get about 20 or 30? I could be wrong. All right, so the second one, the same. It's the same. It's bouncing. I'm going to call it right here. It looks like about right here. And for the third one as well, starting at 70, still the same. You've got about 20, maybe it's 25. It goes so fast you really can't see. Okay, so in our initial control test, all three balls are the same temperature, and they all three have the same drop from 70 centimeters, and then they all bounce. Their initial bounce is, for this example, you could use 25 centimeters. Okay, so we're ready to go on to part 2. So here we go again. Now we've got something a little different going on. So make sure you note this in your data table. So the ball with 1 stripe was placed in a freezer overnight, so it is 0 degrees. The ball with 2 stripes was in an oven at a temperature of 40 degrees Celsius. And then the ball without a stripe was left at room temperature of 20 degrees Celsius overnight. Okay, so we're going to start with, this is the room temperature ball, right? Room temperature, 20 degrees Celsius, so this would be its initial temperature, starting at 70. So what do you guys expect it's going to do? Right, same thing. Thank you, Cole. Perfect. It did the same thing. So 25, 30 centimeters. Second one, the 2 stripes, this was frozen, right? No, the 1 stripe was frozen. So let's see what happens. 70, it really didn't bounce. Or maybe it went like 1 or 2 centimeters. I'll show you again. There's really no bounce, maybe 1 centimeter. Oh, I'm still screen sharing. There might be lag. So now let's try the one that was warmed up, right? This was in the oven. So 70 centimeters, it bounced a lot higher. So a little bit hard to see that. Our trial one, I would say like 50. Yeah, 50, 55, excellent. So you would need to do that 3 times. So if you're creating your own data table, you haven't done this, you just go into the lab, you drop this 2 more times. That looks like maybe 52, 1 more time. So the warm one, 55. Room temperature is going to be the same, 35 or 30. So you have 25, 30, right. Okay. So that is pretty much the guts of the experiment. We've done everything we need to do, and now we're ready to write the lab report. So I'm going back to my slides because the lag is so bad. And we are going to take a look now at writing the lab report. Okay, so we looked at the experiment, and then the next page says, okay, so hold on, questions. Nope, so Andrew, this is simulation. So 1.11 is a simulation. You're using 1.8 data. All right, so this is at the end of 1.8, and it's also at the beginning of 1.11, so that you're able to know what needs to be included in your lab report. So a couple of things that I want you to answer. In your introduction, you need to make sure you define what elasticity is. If you go back in the lesson, you may remember now, there is some topic about elasticity, and there was a definition given in one of the very first lessons. Okay, so making sure there's no questions. So our introduction is going to cover what elasticity is, how it's related to the bounciness of a ball. So if you go back into the beginning where it talks about like matter and energy, you'll see a little bit about that. And you can figure out what to put there. And then what's the purpose of our experiment? Remember we had that question at the beginning. So we are testing what does the temperature, how does the temperature affect our elasticity? Okay, so next, when we get to the discussion and the conclusion part of our lab report, we want to make sure we answer these 3 questions. So what do the results indicate? So we need to compare and kind of understand how those 2 things work together. You're going to want to tie your data in. So if you guys could keep the chat focused on what we're talking about, because I know there are students that have questions, and I don't want to miss the questions. Okay, so we'll chat in just a little bit. You'll have some more time. So discussion and conclusion, make sure you answer the relationship between temperature and height. Make sure you tie in your data. What are some sources of error? So we saw that. You guys could see that the ball may not be at the same exact same mark on the ruler each time, things like that. Those are sources of error. And then what are some of the ways you could modify the experiment? So that's just your own ideas to see if you could do anything different to get better, more accurate results. And the lab rubric, I really don't use the rubric a whole lot as long as you're answering the questions. All right, so let's take a look. For those of you that may need help again, this is the assessment portion of the lesson. So when you are scrolling down and looking, you're able to print out that lab report here again. Okay, it's in digital materials, and then right below that is the Dropbox where it says upload your file. So that is where you submit your file for grading. And so each Dropbox is specific to the assignment. So you don't want to put anything but 1.11 in the 1.11 Dropbox because it will only be attached to the 1.11 grade and it won't help you out. It'll kind of make a mess. So each lesson is specific to the Dropbox it's in. All right, so the next thing we're going to look at, the lab report. I had a lot of students not read the directions here really clearly, so I'm going to read those to you, and it might trigger like, oh yeah, I need to fix this. So it says, use the document as a template for writing your lab report. Descriptions of what to include and examples of each section have been provided. Before you submit the document to your teacher, delete all the text in brackets, including this text. So all this should go away. It's a guide for you. So you've read this part and you don't need it for anything else. So on your Word document, you're going to want to delete it. Okay? And then the next part, the title. You're going to delete what is in brackets. So you need to title your lab report. What did you guys put for your lab report title? So go ahead. Temperature's effect on bounce height. Perfect, Cole. Yeah, the lab is not about pennies at all. This is a description of another lab to help you understand what each part is asking. So that's why I say read carefully. Okay, so good title, drop and bounce lab. You can go a little more in detail. Cole had a great example too. So let's keep our chat focused again. Yep, drop and bounce lab is great. So you would delete everything here and just put drop and bounce lab or whatever your title is. Okay, so no brackets, no example, no anything like that. And then as we go down to the introduction, it says this section describes the principles and concepts related to the experiment. It's used to help the person reading your report understand the information that serves as a foundation for the experiment, and it also includes a brief statement about the purpose of the lab. Okay, so the example that they gave is the surface tension lab. So again, we're not doing anything with surface tension, so your answer should not include anything about surface tension. Okay, so you'll go through and delete that. And this just gives an example showing you how those questions that we saw in the beginning, how you might tie in some of that data. So surface tension is the attractive force exerted on the surface of molecules. So remember when this lab asked you about elasticity, you would plug in elasticity, how it's related to the bounciness of the ball, so you're tying that in. and then you're tying in that last question, the purpose of the experiment. So the purpose of this experiment was to see if heat or cold temperature at all affected the bounciness of a ball. Okay, so you're going to delete all of this, nothing about surface tension left in your lab report, and then you're going to type your own introduction. All right, so I'm going to turn chat back on really quick. We have a couple that are having a hard time staying focused. So if you have questions about the title, introduction, if you could let me know. All right, then we can go on. Good deal. Okay, so data and observations. So this section is where you are going to plug in all that data. You're going to have a data table that you created, and you're going to share your observations. So it says it's important that the data is easy to read and interpret, and it has appropriate labels and descriptions. So looking at this data table, you should know that this is not enough columns for what we were testing. So using this data table, even if you were to delete some of the things out of it, still doesn't have enough columns. All right, so you guys shared a little earlier that you needed, add an extra column on there. You need to have a title. So you'll need to erase all of this stuff, and either you can copy paste your own in, you could snip, like screenshot and paste your own in. But you'll want to have the temperatures, the different ball labeled, the different trials and times, heights, bounce heights, all of that. So any questions on the data table? All right. Bye, Jacqueline. Thanks for coming in. Yep, so you have the ball, the bounce height, all of that stuff in your data table there. So you do need a title, your data table, and then if you want to type any observations, you can. So if it's something that maybe you were just looking at and you saw a color change or something in an experiment like that, you would type the observations instead of your numbers. So this is really for qualitative data, and up here is for quantitative data. Does that make sense? All right. So there's not really any qualitative data here. You don't really have to type anything you observed here because all of your data was in numbers. Okay, so all you need to do is put your data table in. And if you remember when we looked at that slide, I have it here again. We had a title, and we had the different columns, trial 1, trial 2, trial 3. You had an average, and you had maybe ball 1, ball 2, ball 3, something like that, temperature. All right, so that's what your data table will look like. Okay, finally, we get into the discussion and the conclusion. So it says, use the question in your lab to complete the section. So you'll go back up. What were we testing? We were testing, does the temperature affect the bounciness of the ball? Remember, over on, if I go back a few slides, we had these things that we wanted to include in the discussion and conclusion. What were the results? What was the relationship? You'll want to pull in some of your data there. Some of the sources of error, all of those things are things you would want to put in your discussion or your conclusion portion. Okay, so this is in your last paragraph. All right, so as we go forward, it says, here's an example. It's showing you how they tied in the data. It says soap reduced the surface tension of water because only 10 drops of water and soap were added to the penny before the liquid spilled over, compared to the 50 drops without. So they're pulling in the data from their chart and explaining how it answered the question. So for you guys, you shared earlier your results, and you said the temperature of the ball did affect the bounciness, and that's where you would say the ball that was in the oven bounced, and give that average versus the ball that was frozen and give that average. So that's how you would tie in the numbers. Does that make sense? So this isn't a whole paragraph. If you look at this last conclusion, it's just a few sentences restating what you were answering, what your lab was about, and what information you found. And then so be sure you delete all of this about the soap, the pennies, the brackets, all of that, and put your own conclusion there. Okay, any questions on that? Okay, everyone good? Great. So as we go on, I'm going to share really quick with you a couple of things. This is a lab that you can probably just type up. You don't have to, really, there's nothing to write or draw in, so you're good to go there. Just type it up. If you had to write it in and needed to take a picture of your lab, there's instructions there. For steps 2 and 3, that's how you might do that if you had to. Remember that when you are submitting a file, I get a ton of blank files. So students maybe downloaded it and then they saved it and then they saved their other copy and they didn't know the difference and they submit the blank copy, and that just makes extra work for me and you. So please double check that your file that you're saving and uploading into the Dropbox maybe has your name or some indicator that you know that it's the file you typed on. Okay, so blank files do get a 0. And then you have to go back and read the feedback to know what the issue was, and a lot of you don't read your feedback. So you never know, and you're like, Ms. Reitzer, I'm waiting on you to grade this. So Tia, yes, this is going to be recorded. And I'll say, well, I did grade it, and in your feedback I told you that the file was blank, and you still have a 0, so you need to fix the file. And so there's this waiting game of all craziness, so you don't want to do that. Always read your feedback, it's in the course, and always check if it's a 0 that I didn't tell you, hey, your file is blank, okay? And then remember that all of your documents that are submitted, if you work on a Mac, I can't accept Pages. It will not open on my computer. So if you have a Mac and you don't have the Microsoft Office products, you need to download that from your student account. I will actually put the link in chat for you guys on the instructions to do that in case you aren't familiar with the free Office 365. If you do a PDF, totally fine. So for you guys that may be working on a Mac, if you just save it as a PDF, that's like a universal happy document, it will work. Okay, so that is all I have for you guys. If you want to stay and hang tight for a little bit and get the link to the how to install the Office 365, I'm putting it in right now. You do go through your Outlook. It shows kind of an outdated version in this document of going through our old system, but it does, you'll see the next picture, and it will talk about Outlook, so you can do that. You guys will also see the session coming up Thursday, and that will be our flipped follow-up for the week.